Welcome back, and here's another example. This one I actually had to do in college as a project and draw like a nice diagram, do all the nice math. This was effectively a professional problem that I had to do in college. So it's kind of near and dear to my heart. But so we have an oil refinery located on the north bank of a straight shoreline. Okay, so straight shoreline here is going to be the oil refinery. Okay, and a river that is 2 kilometers wide. Okay, so I'm just going to make note of that. 2 kilometers. And a pipeline is being constructed from the refinery to storage tanks located in the south bank. Okay, so here's the tank. Okay. South bank that is 6 kilometers east. So I'm just going to say from here and then to here. Okay, if I were to go across and then over, right, this is going to be 6 kilometers from there to there. Okay. Let's see, 6 kilometers east of the refinery. Cost of laying a pipe is that. So okay, so cost over land is 400,000 per kilometer, and the cost over water is going to be $8,000 per kilometer. And then we want to minimize the cost to construct this pipeline, right? So the idea, and then we want to overland to a point P on the north. Oh, I'm sorry. So we want to lay overland until point P, right? And then from point P, so effectively we're going from here to here, and then we're going to go from there to there. Okay. We want to find the location of P. All right, so this is where we have to do a little bit of geometry. Okay, so I'm going to say here we have another little triangle. Here's a nice square. I know that this is 2, right? And if I want to call this x, right, because that's really what I want to know. This is my first distance, right? And then the second distance that I want to know is the hypotenuse here. But ultimately, I want to know how far I have to go down from the oil refinery before I go underwater. Okay, so here we have our setup. Okay, so then what is this down here? That would be 6 minus x, right? Because I have 6 kilometers horizontally to go in total. All right, so just so we're clear, I do want to define x. X is the amount or the number of kilometers by land to point P. Okay, and I can compute D2, right? D2 is going to be the square root of 4 plus 6 minus x all squared. Okay, and simplifying that, that would give me 40 minus 12x plus x squared. Okay, so now I'm wondering, I've done a bunch of work, but what am I actually supposed to do? I want to, minimize the cost, right? Okay, well, then the cost, I need an equation for cost. Okay, so cost. Okay, well, it's going to be some amount related to D1, right? And then there's going to be some amount related to D2. Okay. Okay, so I know, okay, this is where I have the 4,000 and 8,000. Okay, I'm getting close. So distance 1, right, that's over land. So it's going to cost 4,000 or $400,000 per kilometer. And I have X kilometers, right? So I go some distance X, and that would be the total amount for that part. Okay, for the water part, that's going to be 800,000 times whatever that distance is, times D2. But wait, I have an expression for D2, so that's just going to be the square root of 40 minus 12x plus x squared. Oh, okay. That's not too bad, right? Well, before I go on, I should check my domain. Okay, so what is x? Okay, x should be something that is less than 6 and bigger than 0, right? Because I can't go all the way across, I can't go all the way to directly across and down. I could, but then it's going to be pretty expensive. And similarly, if I just went over water only, if x was 0, that would be straight down the shore. Okay, so I can't have x as either one of those. Okay. All right, so open interval again, I have to use the first derivative to find the critical number. So c prime of x, and you can have fun with this, but it is going to be 400,000. And then plus 400,000 times 40 minus 12x plus x squared to the minus a half, and then times negative 12 plus 2x. Okay? And I'm going to tell you that this gets to be a little long and complicated because you do need to set this equal to 0. Okay? So I want you to go through the algebra on your own. What you end up getting is x is equal to plus and minus, try that again, minus 2 plus or minus square root of 192 over 6. Okay? And we have to toss out the negative, so because otherwise you just get a negative value. And so here we have this. And if you calculate that out, that's a 1.98-ish. Okay, if you round to 2 decimal places. And then from there, we do have to, verify that this is a minimum. So if you want to take the second derivative of that whole thing, you're welcome to. I would probably do the first, and then make a C and a C, or C prime and C chart. Okay, so we're somewhere between 0 and 6, and we're testing this 1.98. So I would maybe say C prime of 1, and then C prime of, C prime of 3. Okay, and if you calculate this out, C prime of 1 ends up being negative, and C prime of 3 ends up being positive, so you do get the minimum feature that you need. Okay, so then the whole thing, the answer is the question is, where should P be located? We're going to say P should be, be located 1.98, or I mean, I should really give the entire expression. Negative 2 plus square root 192 over 6 kilometers east of the oil refinery. Okay, so, and that's also assuming that they have the land for that too. But anyway, I believe we've gone through and solved this problem completely from start to end. The idea here again was to get a good diagram going and then recognize from the geometry there are some constraints that were given, mainly that if we let D1 be x and D2 be this other red line here, we're able to find D2 using the information given in the problem of the river being 2 kilometers wide, and then we have to be 6 kilometers down shore in total, or east of the refinery in total. Okay, so there we go.